So I want a P&ID of the control loop for the temperature. What I've drawn here is a kind of very simple version of the level loop. So how can we equate this level loop in temperature? What do we have? What do we need? So what I've drawn here is that we have inside this enclosure, which is what we have in class as well, we have this heating element and we have a sensor here. So this sensor here, how can we equate this sensor? What here equates to that sensor? The measured variable.
The LT.
The LT. The level transmitter is transmitting a signal of the variable level. So here, this is going to have to go to what? What do you think?
To the LT.
But it won't be level.
To the water bucket thing.
What is it measuring?
The temperature.
Temperature.
Oh, so IP.
Sensor. TE. Temperature. What does the E stand for again?
Element.
Primary element, which is a sensor. Now, there's multiple versions of this, so I'm going to give you another version after. So in this case here, what this is a process. This is from a thermocouple which generates millivolts. Okay, we're going to get into that a little bit more later on. So this is a thermocouple. Now from here, what do you think is going to happen?
And then we have a TIC.
You have a TIC. So let me just draw it here, TIC. I'm going to show you, this is just to get you to understand what the components are. I'm going to rearrange all this afterwards. So you can draw this version here, and then I'm going to show you a more polished version. So your TE. Now, this millivolt signal, okay, is not an analog signal. So it's not a dotted line. It's part of the process, like so. It is not a dotted line. It's not an analog signal. There will be another version where it'll be a 4 to 20 milliamp signal. But for now, what we're doing is, this is your sensor. Your controller is measuring that millivolt signal from the thermocouple. And then the goal is what? Well, you have your set point. Do you remember how the output is generated? Set point minus process value. So it calculates the error. And then, do you remember 7 and 8? What was the output voltage for 7 and 8? Was it 120 volts or 24 volts for output 1? I should cue the Jeopardy song. Eh?
It depends what you want. You want to heat or you want to cool.
Well, here we're heating, right? We have a heating element.
So then it's going to be 120.
No, the output was 24 volts, and the output was going to, what was it going to? It was going to an SSR. Guess we're going to have to recap that wiring. This represents our SSR in a plant. So in other words, this here is 24 volts powering up the SSR. This, by the way, is not your typical P&ID. I'm giving you more information than you would find, but it's just so you understand the actual control loop for the temperature. Okay. So this is the SSR, and this actually would be the 120 volts in our case. Okay, so this would be a control loop. Now I'm going to erase this portion here. I'm going to give you another version. I'll just stick the sensor right there. This is a heat source. Another way to show this is basically kind of like intercepting what the sensor is measuring in millivolts. And then you have a TE here. You put that in a circle, kind of like we did for the valve, right? TE. So instead of showing it this way here, this is more typical. Okay? From here, you have your TIC. TIC. And basically, this voltage control device here is your SSR. One other thing I'm going to add is that sometimes you can convert this millivolt signal. Don't write this one down though. You can convert this into a 4 to 20 milliamp signal, and that would then be called a temperature transmitter. Okay. But for now, we won't look at that. Okay, so this is what we've got so far. So this is a P&ID of the temperature loop that we have. So the one on the left will be a bit more precise.
And what does this do?
This is a piping and instrumentation diagram for the control loop. What does it do? It shows you that you have a sensor. So TE, temperature, primary element, a sensor. You have a process. This basically is millivolts. Now we're going to look at the technology behind the thermocouple and how it works today. This is your controller, temperature indicator controller. This is exactly what I have in class that's on the wall. Okay. And then the output, which is 24 volts, goes to a voltage controller, which in our case is the SSR. And then from the SSR, we're supplying power to the element, which in our case is a light bulb. So this is a P&ID of the temperature.